2.
Yes? With what?
It's
With what?
bracket.
Thank you very much. Good. And this one?
2, the parentheses, and
Yes.
an infinity.
Excellent.
Parentheses.
Excellent. Can anyone now give us the entire domain of this function? This is not always going to be the case, but this is a simple example. But domains will not always be all real numbers. It is indeed all real numbers, everything to the left of 2, 2, and everything to the right of 2. So negative infinity to infinity, 2 has to be in the table for sure, because something major happens at 2. There is a bracket right underneath, facing this way, and a parenthesis right underneath, facing the other way. Again, this is an overkill. I agree with that, negative 3x. And this part from 2 to infinity is 2x plus 4. There is no need for this, but it's better and safer to have them above because they may be reversed. Who knows what I'm doing there, just to make sure. Okay, so in 3x, I get 0. 3x and negative 3x, I get negative 6 inside the bracket. Make myself a note, full. 2 in here, 4 plus 4 is 8. And I have to pick another. There is no x-intercept here. The x-intercept is a negative 2, but it's not in the interval. So I'm going to pick 3. 3 times 2 is 6, plus 4 is 10. They are both lines. I need 2 points on this side. I need 2 points on this side. I make myself a note, open. Any questions so far? Any questions so far, please?
No.
Better?
Yes.
Perfect. They are simple. They seem to be very difficult, and many students have difficulties with them. Why? I'm not sure. Okay, ready to graph? From left to right, I have 0, 0. I have 2, negative 6. 1, 2. 1, 2, 3, 4, 5, 6. And it's 2, negative 6, and it's a full point. Done. I'm using a different color. I'm not asking you to graph to the colors, but I'm making a point. 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. And, oh, I rushed. Let me see if I can make it. And 3, 10. This has to be open. This has to be closed. Full point, open point. Now, can anyone give us the range of this function? Can anyone help with the range of this function, please?
Is it infinity?
I'm sorry?
Is it infinity?
From the lowest y value till the largest y value.
Negative 6 infinity?
Yes. With
Bracket, parentheses?
excellent. Perfect. Well done. Thank you so much. The function starts existing at negative 6, and it will exist forever afterwards. Thank you very much. Well done. Okay. There is one topic in this section which is called the difference quotient. It does not belong in this section. We will address it tonight. But before I need to present something else. I need to present 2.3 and 2.4, and then we'll come back and finish section 2.2. There is no point in presenting this before looking at 2.3 and 2.4. The order is incorrect. Okay, so in 2.3 and 2.4, we are talking about lines. We're talking about slope. So the first thing that I would like to show is types of lines. That's the first thing. How many are there? There are four types of lines. This line that you see, it's increasing, which has a slope. So this definition of the slope, as we remember, is m. So m, the slope is positive. It's increasing, positive. The second type is a decreasing situation that has a slope that is a negative number. Here's a third line, which is horizontal, which is very, very easy to walk on, right? The slope is 0. And there is the last one, which is this, which is vertical, horizontal line, vertical line. This one has the slope undefined. It's a fancy word that we used before. It basically means it does not exist. So that's our first situation. We know a lot about lines so far. And we worked on graphing those lines. You also had an example or a problem on the test. And we also know the definition of the slope is rise over run. This is the difference in y, y2 minus y1 over x2 minus x1. And this is the difference in x. Anyone remembers the equations of the line? There are two equations. Does anyone remember them?
Slope intercept form?
Yes. Yes. Slope intercept form. Excellent. Y equals?
mx plus b.
Excellent. Brilliant. Thank you so much. Perfect. And there is one more. So this requires us to have 0, comma, a number. This is the y-intercept. And this, as we know, is the slope. And there is one more, which is the point slope form. Anyone remembers that one?
Is it like y minus and oh, and it's never mind.
Y minus y1 equals?
Yes, yeah. Dimension plus b is something or slope, yes.
X minus x1. This comes from here. If you just replace either one, these with y, and cross multiply, you get this. Okay, good. Let's do some practice. Let me choose a couple of examples so we can work on those. So let's say we are given 4, comma, negative 1. We've had examples like this. And 2, comma, 4. Given these points, find the equation of the line. Find y equals. How do I start? Anyone remembers? How do I start? What do I? Yes, of course. So what I would do, just to make sure I don't miss anything, I will label them x1, y1, point 1, x1, y1, point 2, x2, y2. I would make sure that I write the definition so I don't miss anything. y2 minus y1 over x2 minus x1. And now carefully copy. y2 minus negative 1 is 5. 2 minus 4 is negative 2. So I know that the slope is negative 5/2. Okay. None of these points is 0, comma a number. I cannot use this, but I can use this with any point that you want. It doesn't matter. If you use this, you'll get the same equation. You will use this, you're going to get the same equation because you used both to determine the slope. It doesn't matter which one you pick, but you have to pick one. So, which one would you like to pick? And then we have to use this equation. So y minus y1 equals the slope times x minus x1. Which point would you like to use? It doesn't matter.
Two comma 4.
Perfect. So 2, comma 4 and negative 5/2. I recommend writing them underneath. It's safer. And now you can plug them in. So y minus 4 equals negative 5/2 and x minus 2. You have to solve for y. You have to distribute negative 5/2 to both. And you have to add 4 to both sides. So y equals negative 5/2 x. Negative 5 over 2 times negative 2 is a positive number, and it is 5. Because you simplify the 2 with the 2. Negative times negative is positive. Simplify, you get 5. And I have to bring 4. When you bring 4, you change its sign. That's all you need to do. Y equals negative 5/2 x plus 9. And this is it. Given the 2 points, I was able to determine the equation of the line passing through those 2 points. There is no other equation that passes through those 2 points. Okay. Now, one other thing that I want to mention here, do I still have a minute? Yeah, I have 3 minutes. Parallel and perpendicular lines. 2 lines are parallel if they have the same slope. They never meet. So this line is parallel to this line if m1 equals m2. This slope, the slope of the first line is m1, the slope of the second one is m2. If they are equal, the lines are parallel. If the lines are parallel, they have to have the same slope. If they have the same slope, they are parallel. Now, perpendicular. So here's an example of perpendicular lines. So this is m1 and this is m2. This is the line with a slope m1, this line with a slope m2. They form 4 90 degrees angles. They are perpendicular. 90, 90, 90, 90. What is the relationship between the 2 slopes when they are perpendicular? I personally like to remember it as the product multiplication, the product equals -1. You may have learned it in the same way, it's the same thing. You may have learned it like this. But this is even more difficult to say. I'm not lazy, I can tell you. M1 is the negative multiplicative inverse of M2. But if you cross multiply, you get this. So which one is easier to say? The product is -1 or the slope of one line equals the negative multiplicative inverse of the slope of the other line. It's up to you. Both are as the same. I will never use this. Easier to say the product is -1. But everybody has a style. You use your you create your own. That's fine. Good. Let's take a look and see a few things before we look at more problems. Okay, so, oh, yes. Okay, I'll stop. I'll be quiet for 20 minutes, for 10